All right, my name is Stephen Roth, and I will be conducting today's HVAC ResLoad-J webinar. And this app is an iPad app, and as you can see on the screen here, this app is, I'm displaying it actually through my MacBook, through what's called an emulator. And the emulator actually emulates the exact behavior of the iPad app. And it's great for not only testing the app on our end, but also for demoing and doing webinars for all of you. And a really cool thing that Apple's doing in the next version of macOS is they're going to actually allow anyone to use an emulator on their macOS. So in other words, all of our apps will be available on the MacBook, which we constantly get questions about that, probably once or twice a week. When are your apps going to be available for MacBook? Well, finally, after 12 years or 10 years, our apps will be available for the MacBook. So we'll be sending out an e-newsletter probably in the late fall when that actually does happen. So that's exciting. So anyway, as I mentioned, you are looking at my emulator here. It's an exact replica of the iPad app that most or all of you have. And I will be doing the webinar using this emulator. So please feel free at any time to interrupt me, ask questions. Since we have a relatively small group here, actually it's bigger than most of our webinars, but it's a small enough group that you can please unmute yourself, ask me a question or clarification or whatever. I want this to be an interactive webinar. We have plenty of recorded webinars from prior years on there that you could view, but the purpose of this live webinar is to really ask me some specific questions about issues or uncertainties that you may have about the app. So please, as a rule of thumb, make sure you unmute yourself, obviously, ask the question, and then remute yourself so we don't hear any background noise because this is being recorded. All right, so let's get started. As I mentioned, my name is Stephen Roth.
About the app?
I'm sorry, what was the question?
Can I ask about the Mac app?
Oh, sure thing.
Will it be exactly the same, or will it have additional features and more controls?
It will be exactly the same because it's going to run in the emulator just like you see on your screen. So it's going to be exactly the same. Yeah.
All right.
All right. So as I mentioned, my name is Stephen Roth, and I'm the president of CarmelSoft, and we develop HVAC mobile apps. We've had these apps out for almost, 10 years now, since 2010. And we also do a lot of custom software development for ASHRAE and Carrier, Mitsubishi, Trane, a lot of the big HVAC vendors in the industry. And we also do some software consulting for the Department of Energy. So we do a wide range of software development. So, but my favorite part are these apps. These apps are used by literally thousands of people throughout the world. We actually are able to see not who's using the app, but where people are using our apps. And it's really cool to see, like even our free PT chart app, we have 20 people at a time using the app throughout the United States. So it's really cool to see how people are using our apps, technicians out in the field. So that's what's really exciting about these apps. We get a real in-depth view of how people use our apps throughout the nation. So this specific app you're looking at, the HVAC ResLoad-J, performs peak cooling and heating loads for residential facilities. It is based upon ACCA Manual J8 calculations. It is approved by ACCA, and it's actually been approved by ACCA for almost 8 years now. And as I mentioned, it's used throughout the nation by technicians, engineers, architects, and a wide range of professionals. So today I'm going to demo this app for you and show you a lot of the features. If I went into every single feature of this app, it would probably take 3 or 4 hours, but I'm going to give you an overview, and then I can go into specifics into anything that you want. So like as I mentioned, please make sure to unmute, ask a question, or if you want some clarification, and I will go in more depth. All right, so as I mentioned, you are looking at an emulator of the app. You can actually use the app in what's called landscape mode, which is what we're looking at here, a little bit more screen real estate, or you can use it in portrait mode. So you rotate it, and as you can see, the list isn't there, but if you click the little button here, the list pops out, goes back in. So either way, all the inputs are the same. They're just laid out a little differently. And I think most people actually use it in landscape mode just because that list is always there for you to view, and we're able to display more inputs in the landscape mode. So here on the left here, we have a list of all the projects. And a project I would consider a house or a building. Now, what some people do is if there's a big enough house, say with two units, two furnaces, or say 2 separate HVAC systems, they may actually create a project for each system within a house. So you may have 2 versions of a house. The first floor served by the first system, and the second floor served by the second system. That's a great way to do it. There's also another way to do it, which I'm going to show you. You can actually have multiple systems within a project, and I will show you that in a bit. All right, so here we have a pre-populated list of projects. Just for the sake of time, I'm not going to create a brand new project. I'm going to work with an existing project. However, you can create a brand new project by clicking the plus button and then typing in project name, house name, click save, and it will create a new project. What's also nice is you can actually copy from an existing project. So any of your existing projects, you can copy, replicate, and then make the specific changes for that new project. And the nice thing about being able to copy is you can actually create a template, your own template. And suppose you service similar houses, say in a certain housing complex or whatever. You may want to create a template and copy that template over and over again, so you don't have to re-enter data every single time. What's really nice about this is creating that template to save you from re-entering data. In other words, saving time. All right, as I mentioned, I am not going to create a new project for the sake of time here. I'm going to work with an existing project called Ross Residence S1. So if I select it, you'll see that if I select any of these projects, the inputs update on the right here. And these inputs are what are called my project inputs. And these are overall inputs for your project. So you can enter, contact information, address, city, state, zip, country. Now, the most important input in this section here, you click the little caret icon, and up pops your weather data form. And there's about 1,000 cities in this database. If your exact city isn't in here, select the city that's closest to yours. You can also map it. Now, the map it doesn't work well on the emulator just because my MacBook doesn't physically know where it is, unlike my iPad, which knows where I am. So if this was an iPad, it would actually, it could map it to my exact location, and then you'll see push pins. And then you'll select the push pin that's closest to your location. So if I select that push pin, it selects Fayetteville, Arkansas. Automatically fills in my summer dry bulb, wet bulb, winter temperature. You can override this data too. Just go in there and override it, and it will override it for this specific project. Now, when you come back to a new project, select Fayetteville again, it will then fill in the default data for Fayetteville, but you can override it once again if you want. So now that we have our weather data selected, we can go down here and go to our system general inputs. And this allows us to specify the total floor area for heating and cooling, average room height. And you'll notice here that we have a maroon number here. So what does that mean? Well, suppose I go in here, and actually let me use the slider control. So there's a couple different ways to input data. You can actually put your finger in there and enter a value using the keyboard, or you can also use the slider control. And as I move my slider control, you'll see the numbers update. Now you'll see that this maroon number, which is my heating total floor area, moves in sync with my cooling. So what maroon means is it's a number that's derived or calculated from another number. So as I move my cooling floor area, my heating floor area automatically updates. Now suppose my heating floor area differs from my cooling floor area. Well, I just go in here and override it. Suppose I have 4,000 square feet of heating. Well, now you can see that it's overridden and they're no longer in sync. And they each have their own values. Now, if I want to go back and put them in sync, I just delete the value, click done, and now you see that they're in sync again. So that's my total floor area, my average room height. Your room heights are not going to be the same in every single room, but just enter the average. And the real goal here is to get your volume of your home or your building. So it's basically multiplying your total floor area by the room height to get the volume of your building. The reason we need the volume is for calculations for ventilation loads and also infiltration loads. That's what it's mostly used for. Number of bedrooms I can enter here, and it will calculate the number of occupants, basically 1 plus the number of bedrooms. So as you can see here, as I increase the number of bedrooms, it increases the number of occupants. And the occupant load is important just because it calculates your internal load. People obviously give off heat, both sensible and latent heat. So it will add a little bit of internal load based upon the number of occupants. Now your appliance load, this is a cool feature here. So the appliance load, you can either say, you know what, my appliances add about 1,200 BTU per hour of load, or maybe medium would be 2,400, high would be 3,400, or you know what, I want to create a custom list. I want to list all of the appliances in my home. So I click custom, click the caret, and up pops a form where I can start adding appliances. So if I click the plus button, and then I click this caret, you'll see that there's a whole list of appliances that I can add here. So let me add a color television. And let's say I have, 3 of them throughout the house. And it auto-fills in my sensible, and it automatically calculates a total sensible BTU per hour load of about 2,000 BTU per hour. Now, you may want to say average in use, like, a lot of people watch a lot of TV. I don't think people watch 100%, of the time, they don't have the TV on 100% of the time. You may want to say, you know what, I think I have TV on maybe 50% of the time. You can enter 50%, and it halves your BTU per hour. So let's add another appliance. Let's add a dishwasher. And let's say we only have one. Now, dishwasher obviously has latent load since dishwasher uses water. And so here's my total sensible and latent load for the dishwasher. Okay, let's add another item. Add a computer. And let's say we have, these days, people have lots of computers, so 5 computers, typical sensible load for a computer, in-house use, average in use. So let's say it's about 2,700 BTU per hour. So you can add as many appliances as you want here. And we'll just add 3, just for the sake of time. And then click done, and it automatically adds all those sensible and latent loads up. And here's my total appliance load. 5,000 BTU per hour, and it adds it into my internal gain here. Now, the nice thing is you can actually split these appliance loads within your rooms, which I'll show you in a bit. All right, so I've been referencing this little area here. So this is a nice little feature here because it instantly provides me feedback of what my load is, and also a breakdown. So you can see my cooling load breakdown between windows, envelope, infiltration, internal load, etc. My total load, my total airflow. I click heating, same thing. And then the AED curve. Well, what is that? Well, if I click the little calculator icon to calculate it, AED curve is adequate excursion diversity curve. And basically what that is a simple load profile going from 8 a.m. to 8 p.m. of my cooling load throughout the day. And as you can see, it peaks around 1 p.m. and then starts to fall off. So the interesting thing about this is this curve will vary depending upon, how your windows and envelopes are situated. Because obviously, if you have windows facing east, your peak load may be in the morning. But if you have windows facing south and west, your peak loads will be more toward the afternoon. And this AED curve can be for the whole building, which you're seeing right here, but it can also be room by room, which I'll show you. Now you'll see these 2 horizontal lines. So if this AED curve, the peak of the AED curve goes above this top horizontal line, that means most likely you probably need a VAV system because you're not adequately diversified. If you're below this top line, you're okay with a constant volume system. So once this peak gets above the line, it will give you a warning saying, you know what, you may want to select a system type that is multi-zone VAV. So that's what this is for, and this was actually required to be approved by ACCA because we want users to know that whether their system is diversified or not. All right, let's move on. So sometimes this isn't obvious, but you can actually swipe the screen, and there's a whole new set of inputs. I can't tell you how many calls we get saying, hey, how do I set my cooling set point, my heating set point? Well, just swipe the screen. And you can actually see
about the system choice that you just described.
Sure.
What would you use for like Mitsubishi splits, for example, or any like wall unit split system?
Well, I would select, single zone package or split right here.
Okay.
Yeah, that's what I would do.
Okay.
All right, so you can swipe from right to left and you get a whole new set of inputs here. And the way you know that is these little dots at the bottom. The dots mean that there's more screens. Now, what's interesting is, luckily this is an iPhone, but on the latest iPhones, now that we have this, there's no more button, but latest iPhones, it actually blocks these buttons on another app. So it's not a problem on the iPad yet. So you should see these buttons, meaning that there are more screens that you can swipe. So here you can set your cooling set point and your heating set point, and you can use it, the slider control. And as you can see, as I move my slider control, you can see how it's updating the pie chart and all the load breakdown on the right there. And obviously, the higher the cooling set point, the less your cooling load is. And then if I do my heating set point, same thing. The higher my heating set point, actually the higher my heating load, obviously, and the lower the heating set point, the lower the heating load. Here's my indoor relative humidity, which I can set. Usually we just leave it at 50%, but sometimes you may want to change that. The cooling supply and heating supply air temp, this is obviously the temperatures coming off your coil for cooling and heating. And in fact, the cooling supply air temp is probably the more important one in terms of determining your airflow. We get a lot of questions about this. Like, why is my airflow appear so low or so high? Well, airflow is calculated by your total cooling load divided by a factor 1.1, which is typical for 0 feet elevation, times your temperature difference, meaning your temperature difference between your cooling set point and your cooling supply air temp. So if you notice what I'll do here, if I'm going to lower this cooling set point, cooling supply air temp to 50, see how it changed my airflow? It actually reduced my airflow because my denominator is now greater. If I change it back to 55, my airflow increases. So if you feel that your airflow doesn't really correlate well with your cooling load, you may want to change this value here because this value is used to calculate that airflow. Another factor is, as I mentioned, there's this 1.1 coefficient, which is for 0 feet elevation. Well, if you're in Denver, which is 5,000 feet above sea level, that 1.1 becomes a lot less, like 0.8, 0.9. So that does also affect your airflow. So the same house in Denver will have a different airflow than a house at sea level, say in San Francisco, assuming the outside air temperatures are the same. All right. System additional inputs, construction tightness. If it's a new home with new windows, double, triple pane windows, sealed doors, you want a tight construction. If it's maybe an 10, 15, 20-year-old home that hasn't been renovated in a while, maybe it's average. If it's a really old home from the 60s that hasn't been renovated, it's a loose construction. And what this affects is your infiltration. If you have a loose construction, it will affect your infiltration calculations. I'm going to set it to average. So speaking of infiltration, let's go in here. So infiltration can get quite complicated if you want it to be. So there's three different levels, three different methods of infiltration. There's the Manual J air change method, the blower door method, or the direct entry method. So the Manual J method is relatively simple. You just say, hey, how many exposures does my building have, my house have, and my construction tightness, which I just selected. And it automatically calculates the air changes per hour based upon the volume of your home. Remember I talked about that before. And it calculates your CFM of infiltration. Blower door method is much more complicated. This was required to be implemented in this app to get approved by ACCA. I'm not going to go ahead and explain it because only a handful of people have ever called us about it or use it. But if you do use this method, it is spelled out in the ACCA Manual J8 handbook. Then finally, the direct entry method is, you know what, I know exactly what my CFM is or my air changes per hour are. I can just enter them right here. So most people use the first method because it automatically calculates it for you. So that's just for cooling. You can also have infiltration for heating. Obviously, in the winter, the winds are greater in certain areas. The infiltration is going to be a little different. And it's also based upon the number of fireplaces because, you know, you may have, especially if it's windy out, you may actually have some infiltration through your fluid there. So you want to enter the number of fireplaces and also how tight is that fireplace in terms of construction. So these are your infiltration inputs. Furnace burner input really is not used, so I'm not going to explain that. Blower heat, you know, all this affects is it adds around, I think, 1400 BTU per hour to your blower heat gain load here. That's all it does. Ventilation rate. Well, there's two ways to do ventilation. There's automatically calculate, which as you can see in the marin value here means it's automatically calculated, or you can manually enter it. So calculating the ventilation automatically, the app takes into account a number of factors, including your total house volume, your infiltration, and also your exhaust. So it takes into all these factors and automatically calculates how much ventilation is entering, you know, through your furnace. And obviously, the higher your ventilation, the higher your ventilation load. And as you can see here, we have a ventilation load of almost a half a ton. So if you say, you know what, I don't have any ventilation, I don't have any outside air coming in through my furnace, just enter 0. And you can see my ventilation goes down to 0.
What would you put for a balanced system? Just 0?
I'm sorry?
What would you use for a balanced system if you have a balanced ventilation system where you're supplying and exhausting?
If it's both supplying and exhausting, you're still, and that air is coming into the furnace, you're still, you know, conditioning that air. So you would need to somehow determine, you know, maybe look at the nameplate data on that furnace, how much, you know, CFM of outdoor air is coming, you know, is allowed to come through that. Because even if it's balanced, it's still being conditioned. So you need to account for it.
Okay. I was actually talking about like a Zender ERV system where there's no furnace, it's just the HVAC.
Oh, so are you talking more commercial type?
No, residential. You use an ERV system.
Yeah.
That exhausts about the same amount it supplies, and it reheats on the ERV reheats to about 85% efficiency, 90% efficiency.
Yeah. So in fact, we have an input here where you can enter heat recovery.
Yeah.
You can enter that 85%. And once again, I think it just depends on, you know, you would need to see how the system is set up in terms of the amount of ventilation.
Okay.
You can enter your heat recovery percentage here, so that will account for it.
Okay, great. Thank you.
Yep. So here I manually enter 50 CFM. You can also enter exhaust value here, and sometimes the exhaust value will change its ventilation because, as you know, the caller, as the person just who asked the question mentioned, you know, it depends if your system is balanced or not. If suppose you have a lot more exhaust than you do have, you know, air coming into the house, then you may have an unbalanced system. So it actually may pull in more infiltration than ventilation. So all three of these sets of inputs really are interrelated. So the fact that you may enter an exhaust value here, it may change your ventilation or it may not change. It depends upon how great your exhaust value is.
Does that have anything to do with the bathroom exhaust fans?
Yeah, like I said, you can enter that, but it may have no effect. Like, for example, let me enter 15 CFM of exhaust, and let's see if it makes a difference in my load at all. I don't think it will. Let me,
So it doesn't calculate the 62.2 ventilation standard.
Oh no, it does not. This does not do 62.2. No.
Okay.
Yeah. Yeah, we actually used to have a separate app for that, but I don't think it's no longer available.
So if we calculated it, let's say it was 60 CFM continuous, we'd put it there instead of 15, we'd put 60 there. Is that correct?
Yep.
Okay.
So I can enter 60, and as you can see, it does change my load a little bit because now the balance of the system's changed. So if I entered 15 again, you'll see my load changes just a bit. See how it affects my infiltration and ventilation, because it all deals with how the system is balanced. If you have a ton of exhaust air, you're going to obviously pull in a lot more infiltration if you have a leaky windows and doors. So that will affect my infiltration load and possibly my ventilation load. But if I have a little bit of exhaust, it may not affect my infiltration too much. So it really is all interrelated, and all the calculations are in the Manual J8 handbook.
Okay, thank you.
All right, I just need to bring up the keyboard again. Bear with me. There we go. Okay, so let's talk about Duct. So we get a number of questions about this. One thing I do want to emphasize is this is not a Manual D application. This is a Manual J application. We are working on a Manual D application since we do get requests for it, but it is separate. It will be separate. This functionality here, the main goal is just to calculate your duct heat gain and loss. So you try to approximate the type of duct system that you have in your home and the amount of square footage of duct, so we can calculate how much heat gain or heat loss is due to that duct system. And you'd be surprised on an unsealed leaky duct system how much it will add to your total cooling load. It could add tons of cooling, literally. So here, I can add as many, I think up to 5 different systems. Here I just have one system. And then let's talk about our supply system. So first we specify where is it located. And you have a couple options here. Let's say it's located in our unvented attic. And then, what's the supply duct system type, radial or trunk? What's the duct configuration? Single story, 2-story, let's say it's a single story. What's our ceiling type? And this will be used if we have an unvented attic and a couple other options. And these ceiling types actually come from the ACCA Manual J8 handbook. Also, you can see it under the envelope tab, which I'll show you in a bit, under roof, and it will explain what these different codes mean. What's our duct R value in terms of the liner or insulation? And then finally, duct leakage. Is it sealed and tested? That means it's the most secure and tight, or is it totally unsealed, or is it average? And then finally, what's our duct surface area? So what it does is, if I erase this value here, it will automatically calculate basically 18% of my floor area. And that's kind of what the ACCA Manual J8 handbook suggests. This may be totally wrong. And some people will, have it default to the calculated value, and then they'll see their duct load, and it's way out of whack. So let's see here. Look at my duct load here. It's already almost a ton. That sounds pretty high to me. So let's go back in here, and let's change it back to half of that, about 500 square feet of duct. And that should lower my duct load to about a half a ton now, which is more reasonable. One thing I do want to show you is if I change this to an unsealed duct system, look how it changes my load. I'm almost up to a ton again, 11,000 BTU per hour. So really selecting, having a leaky duct system that's unsealed really does tremendously increase your duct heat loss or heat gain. So make sure you specify these correctly. Now, in terms of if you happen to have a return duct system, you can specify similar parameters. If you don't, just enter a value of 1 here, and it basically ignores your return duct system. But yeah, like I said, we get a number of questions, especially when the duct load looks really high. And it's important that you pay attention to some of these inputs that really do affect it, including, the duct leakage, the duct R value, and the area of your duct. All right, so we're about halfway through this webinar. We got a lot more to cover, so I do want to move on from this part of the app into the other tabs here. And just one other thing, if I swipe again, I can see a kind of a more of a detailed breakdown load of my cooling and heating loads here. And this screen is actually available throughout the app, and I'll show you. All right, so now that we've entered our project information, we can move on. So one thing I did fail to explain at the very beginning, the way this app works is, first you work on the block load. That means you look at the building as a whole. Don't worry about the room by room. Now, this may be the opposite of what some other software tools out there do, because what we geared this for is the guy out in the field. And the guy out in the field wants to size that piece of equipment quickly. And the way to do that is you determine the block load. After the fact, you want to enter your room by room information so you can start sizing airflow for each room or the ductwork for each room. So we start out with the block load. So that's what this means, block load. Then within the block load, we have these 4 tabs here. The project tab, which we just went over. The envelope tab, which is where we enter our walls, roofs, floors, and doors. The window tab, obviously enter all our window information. And finally, the skylight tab. Then within the room by room, we have the same thing. So now that we've talked about the project tab, let's go into the envelope tab. So when we click the envelope tab, you'll see on the left here, we have a list of all of our envelopes. And envelopes are walls, roofs, floors, doors, etc. Anything opaque, non-glass, non-fenestration. So I can add new envelopes by clicking the plus button. I can actually copy from an existing one. So if I have walls that are similar, but maybe they face different directions, I can always copy that wall to a new wall and then change it accordingly. Or I can just create a new envelope and select the properties of it. So let's look at our west wall here. We can enter any description we want here. Now the envelope type, there's a couple different types. There's our wood metal door, above grade wall, basement wall, which is below grade, a partition wall, which is a wall inside our building, but maybe adjacent to an unconditioned space like a garage, our ceiling, or partition ceiling, and our floor. So here we have above grade wall, and then we want to select the orientation of that wall. And then finally, the construction type of that wall. So this construction database literally has hundreds of different constructions, all from the ACCA Manual J8 handbook. And here we have 3 different categories: frame wall, block wall, and alternatives. We select frame wall, we can click through this list, and as we move through the list, you'll see that it updates the U values and a description. And once I click done, it automatically fills in the U value based upon the construction number that I selected, and what's called the CLTD value, the cooling load temperature difference group, which deals with the solar characteristics of that wall. Now I can always override this. So if I select a wall, but I say, you know what, I think that U value is more like 0.25, I can go in here and override it. I can also override my CLTD group. If you don't know what these group numbers mean, consult the ACCA Manual J8 handbook. Down here, I just enter my wall width and my wall height. Once again, I can enter it directly using the keyboard or alter it using my slider control. And as you can see, my values automatically update as I move that slider. So that's how you do a wall. And here we have our south wall. So I'm going to change that to south. East wall. North wall. Change that back to west. All right. So let's look at a floor. So here I selected floor. Here we have 4 different construction categories: over enclosed, over open crawl, basement, and slab on grade. And there's a bunch of different construction types for each of those. And depending upon the floor type that I select, it will fill in the U value for that floor. Then it will have a different set of inputs. Like in this case, because I have a over enclosed passive floor over tight crawl space, it's asking me for the floor length and width, so basically the floor area. And then it's asking me, hey, is this a radiant floor? If it is, it will change your heating load a bit. If I select another type of floor, it may actually only ask me for my floor perimeter length, because that's what's used to calculate your heating load. So mainly floors are used for heating load, not so much for cooling. So there are different, you'll see different sets of inputs depending upon the floor that you select. Ceiling. So ceiling means your roof, basically. Okay, so if I select ceiling here, then construction type, I can say, hey, I have a ceiling that's under an attic, or it's a ceiling that's a roof deck, or roof choice. So ceiling under attic, here I have, say, ceiling under uninvented attic, R13 insulation, or R28 insulation. Or if I select roof deck, I have ceiling on exposed beams. So as you can see, there's a whole different types of ceiling / roofs types that you can select from here. And based upon what I select, I want to specify the orientation of the ceiling. So assuming it's, say, a gable roof, it's not flat, I can specify the direction it faces. Then down here, I can enter the slope relative to the horizontal. So it's 30 degrees above the horizontal. Auto fills in my U value. I can enter the ceiling length and width here, and it calculates my load. Here's for front door. And finally, a partition. As I mentioned, partition would be an internal wall, it's say adjacent to your garage. So partition wall has actually the same construction types as our above grade walls, but this time you're asked to enter the temperature on the other side of that partition. So what would be the temperature in the summer in your garage? Maybe it gets up to 95. Let's assume not quite that high, 85 degrees. Or in the winter, it gets down to 45. Let's say it's 40 here. So now it uses these temperatures to calculate your load across that partition wall. So you'll see these little values here, down here at the bottom, show you the direct load of this partition. So this is kind of useful to see, how much is my south wall contributing to my total envelope load. So here I have my total envelope load. Here is the load, cooling and heating load, just for this particular south wall.
Stephen, I had a question.
Yeah, go ahead.
I was running a simulation where had a garage partition wall, and then I assumed, as you did here, that it was the same construction as the exterior wall. And then I wanted to add a door to that wall. Basically, it's the access door from the house out to the garage. It didn't, and again, it's could be operator error, but the software didn't seem to give the choice of attaching the door to a partition wall. Am I missing something there?
You're right, actually. Yes, the software does not do that. And that's an interesting case. What I would do in that case is just count that door as part of your partition wall, because I don't think that door is adding too much or changing, adding a lot more to your heating or cooling load versus the entire partition wall. So I would just assume that that door is part of that partition. But yeah, you're right. You don't.
Yeah. I agree with you. I don't think that's going to change the load in a substantive way. I was just trying to model those aspects of the problem with the precision that's available. I agree with you.
But you're right. Yeah, we don't have an option for that. You're actually the first person who's asked us about that. So it's probably just not, you can just model that entire partition wall, even if it does have a door.
Thank you for asking that question.
No problem. All right. Any other questions about this before I move on? All right. And once again, if you slide, you see that breakdown that I showed you before. All right. So let's move
Can I
on
ask
to
one more on the envelopes, Stephen?
Sure thing. Sure.
How does one model a exterior wall that is heavily shaded? For example, have a west-facing wall. It's a stucco wall that has an 8-foot porch, a porch with an 8-foot overhang, essentially, that is sheltering it. I don't know exactly how to do that.
You know what I would do? I would model it as a north wall, because the north wall, the way the calculations work, is it assumes there's very little solar load, because obviously the sun, at least in the northern hemisphere, goes along your east, south, and west walls. Your north wall doesn't see the sun. So I would model that wall as a north wall, because there's really no solar load.
Right. I was, what made me puzzle over it a bit, I guess, is that you have the wall, and I consider that as a solution, if you would, to artificially say that my west wall is facing north, okay, and then I'm going to, in fact, introduce the shading of the windows there as well. So I guess I'm double coverage on the for the windows, because they're in fact shaded north-facing windows in the construct that I was going to use.
Exactly. That's what you would do. And I'll show you in the next section where you can assign the windows to the wall. So if you assign windows to that north wall, those windows will also be very, very little fenestration load or solar load.
Okay.
So that's what I would do.
Okay, great. Thanks.
Yeah. And even another thing you can do is you can almost model that wall as a partition. Because, you know, if you remember the partition walls don't have any solar load. All they have is the heat difference across the wall. So you may want to model that wall as a partition. The only issue with that is I'll have to look, but I'm not sure if you can. Let's see, can you select a partition wall? Oh yeah, you can.
Yeah.
Yeah, you can actually assign a window to a partition wall. So yeah, you could also model it as a partition and then assign windows to it. So that's another option.
Help me out here. Let me see. I thought earlier we had said we can't assign a door. Okay, so that's an opaque. Okay, I got it.
Yeah, you can't assign a door, which is an opaque, which is also an envelope, but you can assign a window to a wall and a partition and a door.
Right. Right. Okay, thank you.
Yep. All right, so speaking of windows, here we have a bunch of windows here. Once again, you can add new windows by clicking the plus button. You can copy from existing windows. So suppose you have the same window throughout your entire house, but different windows may be on different orientation walls, where you can create one window, copy it, and change the wall that window is assigned to. So I'll show you that right now. So here we have a west-facing wall. You enter your description, attached to wall, which I just showed you. So this lists all of the partitions which can have a window in it. So here you can see all our walls that we defined under the envelope, and our front door, and our partition wall. So when you assign this west window to the west wall, so now it will assume that this window is facing west, and it will assign all the proper solar characteristics of a west-facing window. And then down here, you can select the type of window. Is it single, double, triple pane? The frame construction. And based upon these combination of inputs, it will autofill in the U value of that window and also your solar heat gain coefficient of that window. And as you can see, these are maroon, so you can override those. If you happen to have, brand new windows with labels on them that show you your R value or U value and your SHGC value, you can enter those right here. The window type, default. If you're not sure what it is, just enter default, or it could be a bay or garden window. And then here, you can enter the area of one window. Suppose you have 5 windows that are all 14.2 square feet. Well, you enter 14.2 here for the one window. You enter quantity of 5, and all that does is multiplies this value times that value. So you could obviously just enter the total area here and just enter 1 here, but that's all these 2 inputs do.
I got 2 questions before we get too far on the windows. They're probably pretty
Sure.
easy. Number one, the window glass door block ID. Where does that come from? You got A. Oh, that's
that's automatic. That's automatic. So
okay. Comes from the window lift.
It's an automatic kind of indicator that just allows you to reference it later on in other reports. So that's all it is.
Okay.
It has no significance really.
Makes sense. I missed that. The other thing on the description, you as you went through it, filling out the information, I would put in the description, that makes sense to me. And then I go on down. Well, then I look up, and then it went back to what it was before. So am I doing something wrong?
Tell me, are you using an external keyboard?
I'm just using an iPad.
Oh, really? Okay. Well, let's try something here. Let me show you. I get a lot of calls.
On an iPad. Had the same thing happen.
It's just a time thing and frustration.
Yeah, no, I understand.
Unless you don't notice that it happened, then it's a problem.
Yes.
Right. So when you enter it, I'm going to type in west-facing wind. Make sure you click the done button to get rid of that keyboard.
Got it.
Let's go down here. Click done. See how it stayed? If I had not clicked that done button, if I just had gone right out, and minimize my keyboard. Actually, it did work in this case, but yeah, it's important that you press the done button. Yeah, there's we get a number of calls about that. So just make sure you're clicking that done button, and it should resolve it. Now, if you're using an external keyboard, it may not have a done button, maybe have an enter button or something. Just make sure that you always, it needs to register that input. So you need to click done or enter or whatever it is.
Perfect. Thank you.
So I get out, go back in. Yeah, now you'll see it stayed, right? Okay. All right, let's move on to shading. So there's different types of shading. There's internal shading, which means your blinds, drapes, roller shades, etc. Just select the type that you have. And then you can select the percentage of the window that shading covers. Most of the time it's 100%. Do you have an insect screen, whether it's none, internal or external, and what percentage the insect screen covers. Here, sunscreen. You may not have a sunscreen, or you may have light, dark, or darkest type screen. And then what's the sunscreen coefficient? Automatically calculates that, and the coverage. How much of the window does that sunscreen cover? Here we have external shading. So, what's your building or your home surrounded by? If it's surrounded by concrete, then more of the sunlight may reflect onto your home, and you'll have greater amount of load due to that. So, most of the time you'll use green grass. And then if you have an overhang above your window, you can specify the dimensions of that overhang here. So basically you enter your average window height, the overhang length, and the distance above the overhang. It does the geometry, and it calculates how much shading it is providing, against the sun over that window. So you can enter that here. There's my load breakdown. So any questions about the window? All right, let's move on to Skylight. So Skylight is just, a window on your roof, right? So same thing, you can add skylights, you can copy skylights. You can assign your skylight to, we'll list only the ceilings here. So I'm going to assign the skylight to my one ceiling that I entered in my envelope section. I can select construction type for my skylight. Curb construction, based upon the combo of inputs here, it will auto fill in my U value, my solar heat gain coefficient, and I can enter the area of one skylight. If I have 2 or 3 of them, I can enter the quantity here, and it will calculate my skylight load. Now you'll notice that there's no shading inputs for Skylight. Well, it's not required by ACCA Manual J8, so we didn't add them, and most people don't really need it or use it. Okay, so we've entered all of our inputs for the block load. So before we move into room by room, let's talk about some of the reporting. So you can access your reports by clicking the little pie chart icon on the upper right. Here are my system reports. They pop up, and I can scroll from right to left and see a variety of reports, including my overall summary report, kind of a rule of thumb checksum report for cooling and heating, my load breakdown report for both cooling and heating and percentages. Here's my room by room report. And then here are some pie chart reports. And you can see here, I can email these reports as PDFs. I can also air print. So if you have an air print enabled printer, you can print to that printer from your iPad. My room reports, I'll show you these after I do the room by room. HTML report, it won't show because this is an emulator and it doesn't have email enabled on it. But what it will do is open your email client and throw in an HTML-based report that kind of is a tabular-based report that lists a lot of your inputs and also your results. And it will also attach a CSV file, which can be opened in Microsoft Excel. And the final option here, email database, which I may have done with a couple of you here, I'm not sure, but email database allows you to actually email me your database. So if you're having an issue, you're unsure of something, you can actually email me the database. I can open it on my iPad and view your project. You can also do it within your own company. So suppose you have multiple iPads and you want to share a project with someone else in your office, well, you can email them the database and they can install it on theirs. The only issue with it is it will override anything that they have. So be careful with that, because if someone has their own projects and they want to keep them, then you do not want them installing your database over theirs. so that's the only issue. Eventually, we're going to convert this to a cloud format so people can actually share projects, but that's down the road. All right, and just want to explain what the I button does. It's our preferences. So this allows you to, if you happen to be working up in Quebec or down in Mexico, change the metric units. These inputs here, some people get confused. They think these inputs are actually applied to your project. No, all these inputs do is affect your slider controls. So this is the maximum value on your slider control for floor. So suppose I change this to 50,000. Go back to my project, you'll see that my max allowable area is now 50,000. That's all it does. It doesn't change any other inputs for your project. So most of the time you want to leave these alone unless you have a huge house or, or you're bumping them against the maximum values for your, windows or your doors or floors. You can change these values. Down here are your company inputs. So this information will be displayed on the reports with your company information. Let's talk about multiple systems for a bit. If I click yes, now by default this is off because some people may get confused by this, so by default we keep it off and avoid confusion. But if I click it on, click done, I'm gonna go back to my project list. Now when I select a project, you're gonna see something different here. You'll see something now, it displays a system list. So now I can actually have multiple systems in one project. So suppose you have a house, a large house, maybe 10,000 square feet. Each floor has its own unit assigned to it. Well, you'd probably want to have a separate system for each of those floors. And this is how you would do it. So by default, when we have that little button clicked off here, it just creates one system, which is this guy. But you can add in a new system and you can copy it. So suppose I want to add another system to this project. I can copy this existing system and then make changes to it accordingly. And as you can see here, same thing. So like I said, most of the time we leave this off because most people just want to deal with one system per project. Or if they happen to have two systems, they just create a new project. So you can do either or. Either way works. But having the multiple system may be a little cleaner, especially for reporting purposes. So for now, I'm going to turn that off. Let's talk about room by room. So as I mentioned, most people, they're going to immediately do the block load. They're going to calculate their total cooling load, total heating load. They can size their equipment based upon that. But they, if you want to go do a step further and, calculate your cooling and heating loads for each room and also your airflow so you can start sizing ductwork, well, you can do that here. Now, the thing about the block load and room by room is the total of all your room loads will never equal your block load. If they do, it's a pure coincidence. And the reason is, your peak loads for your rooms are going to occur at different times. Your east room, bedroom, will peak in the morning, while your west bedroom will peak in the afternoon. So when you sum all the peak rooms, most likely it will be greater than your block load. So some people ask, well, how come the total of my room by room load is not equal to my block load? Well, it's not supposed to be, and never will unless it's a total coincidence. So don't worry if your room by room loads don't equal your block load. The most important thing is that you calculate the individual load for each room, and you're able to size it for airflow purposes. So the nice thing about the room by room mode, though, is you can derive the constructions that you created in your block load. Is there a question?
Yeah, I was going to ask about, for example, in a dining room, you may have an occupant load of 6 or 8 people, where your whole house is really only 4 or 5 people, depending on the bedroom number. So that's going to drive up your heating load in the dining, your heating and cooling load in the dining room. Probably your cooling load more than your heating. But how do you handle that? Because you're going to end up with a total system at the end based on rooms that's going to require a larger system, right? If you can.
Well, if you think about it, because everyone's going to be in that one room, as I mentioned, your peak loads are going to occur at different times throughout the day for the different rooms.
Right.
So, the time of day where you're going to have 6 people in one room, say your dining room or living room during the day, a lot of your other rooms will be unoccupied. So they may not require as much load. So I wouldn't worry about, I would not oversize a piece of equipment just for the sake of accommodating that living room, which has 6 people in it, one day a week for dinner or a couple days a week for dinner.
Okay.
Yeah. As I mentioned, and oh yeah, another thing too is that AD curve that I talked about. If this peak of the curve, if this peak is below that line, then you're okay with a constant volume system. But if this peak goes above that line, then yes, you may want a VAV system because you don't have enough diversity. And then it would accommodate more what you just talked about, where, you have one room that's going to have a pretty heavy load during the day, while the other rooms will not. So you may want to look at this AD curve and kind of see where we're at.
Okay. Thanks.
Yep. All right. So we have a couple minutes left, so I'll go relatively quickly through this room list. So once again, you can add as many rooms as you want. Click the plus button, add a new room. You can all copy from existing rooms. So suppose you have like 2 or 3 bedrooms that are along the same orientation of your home. You can copy those again and then make specific changes. And then, so someone just mentioned occupants. Well, you can actually enter as many occupants as you want. Like even on the block load section, I entered 4 occupants. You can actually enter as many as you want here. So if I enter 9, it's going to let me enter 9, and we'll calculate the load for that. It shows me a counter here saying, hey, I have 0 left, but you can enter as many occupants as you want, even if it's greater than what's in the block load. And you remember the custom load, the custom appliance loads that I defined in the block load? Well, now you can start assigning those to the rooms. Now, why is that not showing up? Oh, I'm in the wrong project. Let's go back here. We'll change that to 9 again. And then, yeah, here we go. So here it'll list all those appliances that I created under the block load. I select the one. I say, hey, you know what? I have 1 TV in my office. And then I also have 1 computer in my office. And then click done, and you'll see that it will throw in about 900 ET per hour into that office. So I can actually assign those individual appliances to each of my rooms. So here's my cooling load breakdown for that room, total load, total airflow, which is really what we want to see, my heating load. And then if I click the little calculator icon, here's my AD curve. So now you're going to start seeing some pretty interesting stuff. The AD curve differs for each room, depending upon what orientation it's facing. Now the AD curve for rooms, you can see here it's way above that line. I mean, we're talking about 1 room here. You're not going to have a VAV system for 1 room. So I wouldn't worry too much if that peak goes above the line here. The main AD curve we're really looking at for is our block load AD curve. But this does show you a nice little load profile of how my cooling load changes throughout the day in that room. Is there a question? We're getting some strange background noise. Looks like everyone is muted, so I'm not sure where that background noise is coming from. So sorry about that. I'm not sure what that is. All right, so anyway, let's look at the envelope. So for my room, I can obviously enter envelope, window, and skylight. So I can add new constructions once again or copy existing. Now the thing is, what I can do is, say for the ceiling in my room, I can derive the construction that I defined in my block load for this room. So for my ceiling, I select the vented attic construction that I defined in the block load. Then I enter the area that's specific to this room. And then it will calculate the cooling and heating load. Same thing for my floor. Same thing for my north wall and my west wall. So basically, you're taking the constructions that defined in your block load and applying them to the individual rooms. Same thing with window. I can add new windows. And then I select the window that I defined in my block load and then enter the area of that window that's applied to that particular room. Same thing for my west window. And here are my loads. And then, Skylight. Yeah, go ahead.
I just had while he's on areas, and it doesn't apply to this window, just jog my memory. The like on the ceilings, I believe that you have, most rooms are not, or houses are not a complete rectangle, but they ask for the length and the width. Well, if you got a real odd shape, what I do is just get the area and take the square root of that, and that's the length and the width. Is that how you do that?
Yep. I mean, the main thing is you just want to get the right area. It doesn't matter if the length and the width are, not exact. It's the area that counts. That's all that counts.
Right. Okay. All right. Thank you.
Yep. No problem. All right. So we defined our windows. There's no skylight, but if there was, I could add one. So, for reference purposes, if you're in your window section under your room by room, it's like, hey, which room am I in right now? We'll just look up here. We're in Ross Residence office. So just look, you can see right here where we are. So that's the room we're working with. Now I go to bedroom 1. Here we have our ceiling, floor, west wall, south wall, and our windows. And there's all our different rooms. So now that I've defined all my rooms, I can go into my reporting. Let's click room reports. And then I can say, hey, what's my office load look like? Here's my total room cooling and heating load. Here's a pie chart breakdown. I can print to PDF or print to my AirPrint printer. I can also display all rooms. And this just allows me to scroll through all of them. Or I can view that one report under the system reports, which provides me a nice, concise breakdown of all my rooms, cooling, heating load, and airflows. So you'll see here, the total of my rooms here, cooling is 30,000 BTU per hour, heating is 40. But actually, if I go back into my system, you'll see that the total block load is 50 versus 70. So there's a difference, and there always will be. All right, so that covers the basic features of this app. If you ever need help, click the help icon. It goes to our web-based help. Also, you can call us. Also, we have all these training videos that we've recorded, similar to the one we're doing today. So there's a lot of online help available for you. Are there any other questions, specific questions, or anything you want me to go over in more depth? I'd be happy to do that.
I have one question on the room by room. The interior walls, do those need to be listed as a partition?
That's a great question, and we get that a lot. No, it does not, because if you think about it, interior walls, most of the time on each side, the set point is the same. As a result, there's no heat transfer. So you can totally ignore interior walls.
Oh, good.
You don't need to enter them.
Less inputs.
Yeah, exactly. It makes it much easier. The only way you would want to enter an interior wall is if the wall was adjacent to your garage that's unconditioned, or to your, some warehouse or whatever that's unconditioned. Other than that, you can totally ignore interior walls.
And like did you say that the room by room, the real reason for doing it is to get your airflow?
Yes.
For the room?
Yes.
Okay.
Yeah. Because you've sized your block load, you know what you're told, you know the size of your equipment, maybe it's a 5-ton, split system. So you have 5 tons of cooling, 60,000 BTU per hour of cooling, and you need to distribute that throughout the home now. So now you know how to distribute it, using these airflows. Based upon these airflow values, you can now size your ductwork and then size the system accordingly. So, that's how it would work.
Okay.
Or if you're looking at, yeah, go ahead.
Well, no, I just wanted to make sure it's not, that's the goal of that, the room by room. It's not anything else. It doesn't really need the BTU loss and gain. It just wants to calculate the CFM for that room.
Yeah, sometimes the BTU loss and gain is important, especially if you have a bigger room. Maybe, for some reason, you have a large ballroom in your home. It could be a huge home.
Okay.
With a really large room. You may want to need the cooling load if you want supplemental cooling, or even if you want supplemental heating. So I think the cooling and heating loads are still important for each room, but it's the airflow that's really used to help size that ductwork.
Perfect. Thank you.
Yeah.
Stephen, I have one for you. Maybe this is more of the philosophy of how you went about designing parts of this. And it seems that, and this Brian's comment about the square root to get the area is what reminded me of this. I observed that the envelopes, there's the input is a width and a length and a width to get, and obviously it's using the area, okay? But on the windows and other features that are under the window heading there, you just ask for an area. You don't ask for a length and width of a window, which is
Right.
how you buy them, if you would. And obviously that's the rough area. I got that. So to me, it strikes me that having to specify a length and a width for the envelope features introduces a complexity that maybe you don't want. And again, maybe it's a Manual J protocol or something, but would it be possible to have a length and a width entry or an area, and if you put in the area, then you're not required to do the other one? Because I do find myself coming up with these artificial lengths and widths just to get the area right.
Well, all you need, you know what? All you need to really do is, like in this case, would be 750. Enter 750 here, and enter 1 here, and it's the same thing. So in essence, you're entering the area here, and you're entering 1 here.
I understand that, but it's very non-physical, because really what the program's looking for is an area, right? I mean,
Exactly.
It doesn't care anything about the length and the width. It's heat.
Yeah, I think I'm trying to, when we initially designed this, 8 years ago, whatever, I can't recall why we instituted that. It may be something to do with the ACCA Manual J8, form that you fill in. I think it does ask for the width and the height, and that's why we did the same thing. So I just think we were replicating what ACCA Manual J8 forms did.
All right, that's fine. That's fine. I just didn't know, what was behind that. Thanks.
Yeah.
Well, that's really nice that where like you put in the 750 for the width and the 1 for the height. Can you do that with the ceiling also?
Yep. You can do that with the ceiling. Pretty much ceiling length and width, same thing.
Okay. Just as long as it comes up to the number that it is, the area.
Yep.
Okay.
Width and height of the door, same thing. Partition, same thing. Yep.
Don't have to use the square root now.
Yeah. No. I think the iPad has a calculator like the iPhone, so you can just use the iPad calculator to do it.
Sure. Thank you.
All right. Are there any other questions at all?
I'd like to make a comment, but
Sure.
The questions I asked were mostly on time savers, and I think that's a big deal by the end of the day. So I appreciate that. It may seem small and insignificant to you, but those little tips and tricks can save minutes, and they add up to hours at the end of the week.
Oh yeah, I hear you. I mean that's why we designed this app, is because we want you to do it quickly out in the field. I mean, you don't want to be out there longer than you have to, especially these days. So this is all great advice.
And I've got a question too. It's I actually split a project because it's a conditioned basement and then a duplex with an attic above it, and I split it into 2. Is there a way to pull it back into 1? Set it up as essentially 2 projects.
No, there isn't actually.
So there's no way I could open one and then import the pieces of the other. There's no way to do that.
Let me see here. I don't think you can. Yeah. No, you'd have to manually enter it if you wanted to do that split. Yeah, sorry about that.
You'd have to, in the other direction, you'd have to do the same thing, right?
Right.
Or you just duplicate the file and delete the left half or the right half. What you're doing.
Right. So like suppose you suppose you entered all your information for the house in this one project, but suppose then you wanted to split it in half. You could actually copy this project to a new project, then start getting rid of any of the envelopes that don't belong in one and that belong in the other, and vice versa. So that's what you could do if you want to have an existing project that you want to split in half. You can do that, definitely.
But the reverse is just fill it in by hand.
The reverse, yeah.
Okay.
All right. Any other questions or comments or anything?
I appreciate it. I did learn several things. I'm kind of new to it. I've been using it for about a month, but nope, I appreciate it.
Okay, no problem. So, like as I mentioned, I did record this, so I'll be posting this recording, and then I'll be sending out a link to the recording to all of you, so you can view it at your own leisure. And I definitely do appreciate all of you attending. I think this is the longest webinar we've ever had. It's great to go over and still see people here, so I appreciate that. Appreciate all your interest. So if you have any questions, feel free to email me or call, and I can answer any specific questions. But with that, I will end the webinar, and have a great day.
You too. Thanks.
Okay, take care.